Hello everyone, welcome to the first lab. So to start the lab, enter the contest. The link to the contest is in the description below. So let's move on to the first question. The first question is Fahrenheit to Celsius. So we have a very basic formula to convert Fahrenheit to Celsius. Let's assume our temperature in Fahrenheit is stored in a variable F. So first of all, we have to subtract 32 from this number. After this, we have to multiply this by 5 by 9. This gives us the temperature in Celsius. So we have to keep one thing in mind. Although this is the formula and this is how we'll do it in our notebooks, but for coding, we have a problem with this part. So when we write 5 by 9, the problem is the compiler thinks that it's an integer upon integer and it divides this and stores the result in an integer. So 5 by 9 is 0 point something, and when you calculate something in integers, only the part before the decimal is considered. Anything after the decimal is removed. So this becomes a 0, and 0 multiplied by f minus 32 becomes a 0. So basically, if we write it in this manner in our code, what we are actually writing is okay. So now we'll just move on to the code and see how we'll actually code this. So first of all, we'll take a float variable f to store our temperature in Fahrenheit and a float variable c to store our temperature in Celsius. After this, we'll create an object of the scanner class to take input from the user. So we'll use scanner sc equal to new scanner system.in. Okay. So after this, we actually take the input. So f is equal to next float. So next float is the function that we'll invoke to capture the next floating point number. In order to capture int, we use next int. In order to capture double, we use next double. So in this case, we use a next float to capture float. After this, we calculate the temperature in degrees Celsius. Please look at it carefully how we actually do it. So first of all, we subtract 32 from the degree Fahrenheit temperature. Then we multiply this by 5. Then we put all of this inside a bracket, and finally we divide this by 9. Okay. At the end, we print it on the screen by using system.out.print command. Okay. So now let's try to run this. Okay. So we can see that the two visible test cases have passed, but now we have to submit the code to check if all the hidden test cases are also passing. So yes, we have a perfect score and all the test cases have passed. So we'll remember this very carefully, that doing this will cause an error. And why will it cause an error? Because the compiler thinks it's an integer upon integer and does integer mathematics there, and 5 upon 9 in terms of integers is 0. Okay. So we won't do this. If we want to do it in a similar fashion, what we can do is we can put a 0.0 in front of it. We can do a 5.0 upon 9.0. So this way our compiler will know that these two are not integers but double values. Now let us move on to the second question. So the second question is area of a rectangular path. So as you can see, we are given a rectangular path and there is a rectangular path around it. So we have to find the area of the gray portion. So the method to do it is pretty basic. We just have to subtract the area of the smaller rectangle from the larger rectangle. That's it. So to find the area of the larger rectangle, so the side of the park is of length L. Okay. Then we have the path of width P on either sides. Similarly, the width of the path is W, and we have path of width P on either sides, top and bottom. Okay, so the area of the larger rectangle is L plus 2P multiplied by W plus 2P. The area of the smaller rectangle is L into W. We subtract both of them to get the area of the path. Now let's see how we'll code it. So first of all, we'll take three float variables to store the length, width of the path and the width of the path. Then we'll make a scanner class object to take the input from the user. So scanner SC is equal to new scanner system.in. So after this, we'll take the three inputs. So first we'll take L. So L equal to SC dot next float. Then we'll take W. So it's SC dot next float. So one thing to remember, the inputs are given in this particular order, L, then W, then P. We cannot take it in any other order, okay? So P is equal to SC dot next float. Now we'll take a float variable to store the area of the path. We'll feed it with the formula that we have created. So it's L plus 2 into P multiplied by W plus 2 into P. We'll put the area of the larger rectangle into bracket. Now we'll just subtract the area of the smaller rectangle from it, that is L into W. Now we'll print the answer on the screen using system.out.print command. Now we'll see if the code actually passes the visible test cases or not. So we'll click on run code, and as you can see, both the visible test cases have been passed. Now we'll see if we are able to pass the hidden test cases as well. So yes, we have a perfect score and we have successfully passed all the hidden test cases. Moving on to the third question. The third question is nth term of an arithmetic progression. So how does an arithmetic progression work? Let's assume that the first term is A. If the common difference is D, the second term is A plus D. The third term is A plus 2D. And so on. So the first term is A, the second term is A plus D, the third term is A plus 2D, and so on. To get the nth term, we have a very simple formula, and we can also see from this pattern, it's A plus n minus 1 multiplied by D. Okay? So now let's see how we'll code it. So first of all, we'll take three integer values, one for A, one for D, and one for N. So we take int A, D, N. Now we create an object of the scanner class to take the input. So scanner SC equal to new scanner system.in. Now we take the three inputs So A is equal to SC dot next int. D is equal to SC dot next int, and finally N is equal to SC dot next int. Now that we have the three required numbers, we'll calculate the nth term. We take another integer, answer, and we use this formula to calculate the nth term. So it's A plus n minus 1 multiplied by D. Now we simply print this number on the screen using system.out.print answer. Now that we have completed the code, we'll see if we are able to pass the test cases or not. Yes, the visible two test cases have been passed. Now let's check for the hidden test cases. Yes, so as we can see, we have passed all the given test cases. Let us now move on to the fourth question. The fourth question is nth term of a geometric progression. So how does the geometric progression work? Let's say the first term is A and the multiplication factor is R. So the first term is A, the second term is A, R, the third term is A, R square, and so on. So we have a very simple formula to calculate the nth term of a geometric progression. So the formula is, and you can also see from the pattern that this will match, A, R to the power n minus 1. This is the value of the nth term in a geometric progression. Okay. So let's see how we'll code this. So first of all, we take three integers to take the input A, R, and N. So int A, R, N. Now we initialize an object of the scanner class to take the inputs. So scanner SC equal to new scanner system.in. Now we will take the three inputs. So A is equal to SC dot next int. R is equal to SC dot next int, and N is also equal to SC dot next int. So now we have taken the inputs and now we need to calculate. So we'll take another integer, answer, and we'll put in the formula. Now to calculate, we need to calculate a power. So there's a library in Java which will help us do that. So first of all, we'll import that. So import java.lang.math. So in this library we have a function to calculate the power. Okay. So how will we calculate it? So it's A multiplied by math.pow r comma n minus 1. So this math.pow function calculates r to the power n minus 1. Now one thing to remember here is that math.pow returns a double value. So from double to integer is not converted automatically. So we have to implicitly tell the compiler to convert it to an integer. So we'll use typecasting here. We'll convert this answer into an integer, then multiply this by A, and then put the value into answer. Now we'll simply print the answer on the screen using system.out.print answer. Now let's see if we are able to pass the test cases. Okay, so we have passed all the test cases and the question is over. Now let us move on to the next question. So the next question is area of a circle. So we are given the radius of a circle and we have to calculate its area. So the formula to do so is pi r squared. Okay, so we'll use this formula to calculate the area and then display it on the screen. So the radius is given in double. It's not an integer, it's a double type of variable. And we have to take pi as 3.14. So keeping these two things in mind, let's get to code. So first of all, we'll take two double variables. One for radius r, the other to store the area. Now we'll create an object of the scanner class to take the input. So it's scanner sc equal to new scanner system.in. Now we'll actually take the input. So r is equal to sc dot next double. Now to calculate the area, the formula is pi r squared, right? So pi is 3.14, pi into r. Now we'll just print the area on the screen using the system.out.print command. Now let's see if we are able to pass the test cases or not. So yes, we have passed the visible test cases. Now let's go for the hidden test cases. Okay, so we have passed all the test cases. The question is done. So now we'll move on to the next question. So the next question is oxygen level. So in this question, we will be given 3 heart rates. We have to take the average of those heart rates, and if it's below 175, then codeman will pass the test, else he will fail the test. So now let's determine if he has passed or failed. Okay. So now we'll take 4 float variables. A will store the heart rate after the first round, B will store the heart rate after the second round, C will store the heart rate after the third round, and average will store the average of these 3 heart rates. Now we'll create an object of the scanner class. So it's scanner sc equal to new scanner system.in. Then we'll take the 3 inputs. A is equal to sc dot next float, B is equal to sc dot next float, then C is equal to sc dot next float. So now that we have the 3 heart rates, we'll now calculate the average. So to calculate the average, the formula that we'll be using is summation of A of I, where I is equal to 1 to n. Basically, sum of all the numbers that are given upon n divided by how many numbers we are given. So in this case, we are given 3 numbers. So it will be A plus B plus C upon 3. Now we'll check if average is less than or equal to 175. Then we'll print using system.out.print that codeman has indeed passed the test. Otherwise, we'll go into the else statement and we'll print that codeman has failed the test. So now we'll check if we are able to pass the sample test cases. So yes, the 2 visible test cases are passing. Let's move on to the hidden test cases now. Yes, so we have a perfect score and the question is over. Now moving on to the next question. So the next question is roots of a quadratic equation. So we are given the values of A, B, C for the equation ax square plus bx plus c, and we have to find the roots of the equation. Okay. Alright, so let's get to the code. So first of all, we'll take 4 double variables A, B, C and D. So A, B, C are to store the values of A, B and C. D is to calculate the value of the discriminant. Now we'll create an object of the scanner class, scanner sc equal to new scanner system.in. Now I'll take the 3 inputs. So A is equal to sc dot next double, B is equal to SC dot, next double, now C is equal to SC dot, next double. Now we'll calculate the discriminant. So D is equal to B square minus 4AC, right? So discriminant is equal to B square minus 4AC. So we'll use this formula to calculate the discriminant. So it's B multiplied by B minus 4 into A into C. So it's B square minus 4AC. So roots of the quadratic equations depend on the discriminant. So if the discriminant is greater than 0, then we have two distinct roots. If the discriminant is equal to 0, then we have a single root. Basically we have two roots but their value is same. And if discriminant is less than 0, then we have imaginary roots. Okay, so now we'll use this structure to answer the question. So first we'll check if discriminant is greater than 0. So in this case we'll take two more double variables to store the two roots. So it's double R1, R2. So value of R1. So the value of the two roots is minus B plus minus root D on 2A. So here we need to use the power function to calculate the square root of D. So first what we'll do is we'll include the suitable library. So it's import java.lang.math. So with this library now we can use the power function. So minus B plus math.pow D comma 0.5. So this will calculate the square root of D. Basically D to the power half. This will be divided by 2 multiplied by A. Okay. Now moving on to R2. To calculate R2 we have a very similar formula, minus B. This time instead of plus we'll do a minus. Minus math.pow D comma 0.5 upon 2 into A. So now that we have the two roots in hand, we'll just print them on the screen. System.out.print R2 plus space plus R1. So why did we print R2 before R1? So in the question it's given that the roots need to be displayed in ascending order. So R2 will always be smaller than R1 because in R2 we are doing minus B minus root D on 2A, while in R1 we are doing minus B plus root D on 2A. So next we'll check if D is equal to 0. So in this case we have a single root, so we'll take just one double variable R1. Now R1 is equal to minus B upon 2A. Now we have calculated the single root that we have. We'll just display it on the screen. System.out.print R1. Now if D is less than 0, then we have imaginary roots and we don't have to calculate those. We'll just display imaginary roots and we are done. So system.out.print imaginary root. Now we'll see if we have been able to pass the test cases or not. Yes, the visible test cases have passed. Now let's go for the hidden test cases. So all the test cases have passed. Now lab 1 is over. Please attempt all the questions and thank you very much.